Hello everybody, this is the first video for chapter 4 for advanced geometry. We're going to start talking about congruent triangles. So far this year we started with the basic ideas, a point, line, plane. Put a couple of them together, we get some segments, rays, angles, put a bunch of lines together and you start getting polygons. We talked about polygons a little bit, but nothing really. So this is where we start talking about specific types of shapes. And obviously, from the screen, we're going to start talking about triangles. So the first section, apply triangle sum properties, just some of the basic ideas of triangles. All right, hit pause, take a second to copy this stuff down. Very important ideas and terms. So, first off, a triangle. It is a polygon with, it has sides, definitely, but more importantly, it's got 3 sides. Make sure you copy the 3 down and put that in there. So, triangle with 3 vertices, A, B, and C, is called triangle ABC. This is almost always how that will be written. That little triangle symbol out in front, and then the 3 vertices. All right, there are 2 ways to classify triangles. Okay, that's basically just describing what type of triangle it is. So one way is by the sides. A scalene triangle, like it says, there is no congruent sides. Isosceles triangle, 2 congruent sides. And it does say at least, but if there's more than 2 congruent sides, it becomes an equilateral triangle. That means all 3 sides are congruent. The other way to classify triangles is dealing with the angles. So an acute triangle, just if you remember, an acute angle means it's less than 90 degrees. Greater than 0, but less than 90 degrees. So an acute triangle, all 3 angles are less than 90 degrees. If there is one right angle, then it's called a right triangle. If there is one angle that is an obtuse angle, meaning greater than 90 but less than 180, we call it an obtuse triangle. If all 3 angles are the same, equiangular. Equal means equal, angular means angles. So all the angles are the same. So we've got 2 different things to look at to classify it. We can have an isosceles right triangle. We can have an isosceles obtuse triangle. Just different names based on, are you talking about the sides or are you talking about some angles? And at the bottom, the triangle sum theorem. That is something that I think you've known, we've used a few times in certain situations, but you add up all 3 angles of a triangle, you will always get 180 degrees. All right, again, hit pause, copy these things down, please. So, for angles of a triangle, there's technically 2 types. You got your interior angles. Obviously, they're the angles on the inside. That's these red shaded spaces. And then you have exterior angles. Okay, an exterior angle is formed when you have one side and then you extend it out. So, the exterior angle is formed from that extension to the next side of the shape. All right, if we extend this side of the triangle out past that vertex, and then go to the next side of the shape. That's an exterior angle. If we extend this side out and go to the next side of the shape, exterior angle. So, there are actually 2 exterior angles at each vertex. If we look at this as the vertex, this is an exterior angle, that's an exterior angle. You notice they're vertical angles, so they're going to be equal. At this vertex, exterior angle, same thing. Those are the exterior angles. So these are congruent to each other. Those are congruent to each other. At each vertex, you technically have 2 exterior angles. But when we refer to exterior angles of a triangle, we only refer to 1 at each vertex. It doesn't matter which one because they're the same. So we're only going to refer to 1 of them at each vertex for exterior angles. All right. Theorem 4.2 says that exterior angle, the measure of it, is equal to the sum of the two non-adjacent interior angles. All right, adjacent angles are the ones right next to each other. So if we're looking at angle 1 in this picture, that's the exterior angle. The angle that is adjacent to it is this one in blue. The theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So the blue one is the adjacent interior angles. That means the non-adjacent ones are these green angles here, angle A and angle B. And so the exterior angle, angle 1, is equal to the sum of the two non-adjacent interior angles. You're going to hear me use this terminology. Instead of non-adjacent interior, sometimes I use remote interior. Okay. If you think about just like nature kind of stuff, when you say something is remote, that means it's way out there, it's far away. So if we're looking at angle 1 as the exterior angle, angles A and B are the angles in the triangle that are far away from it. And the last theorem is this, corollary to the triangle sum theorem. A corollary is it's something that you can prove. It's just kind of like an offshoot. Yeah, we know the triangles, the three angles of a triangle have to be 180, but here's something else that comes from it. So it says the acute angles of a right triangle are complementary. So angle A plus angle B plus angle C equals 180. Well, angle C is a right angle. That means it's 90 degrees. So angle A plus angle B plus the 90 equals 180. If you subtract 90, you have angle A plus angle B equal to 90 degrees. So what it says is, what this corollary says, if you have a right triangle, the other two angles, the ones that aren't 90 degrees, they're going to add to be 90 degrees. All right, that's it for the notes part. Next video is going through and working through some of these examples.